Hi, I'm Nora McSwain, and for my project, we grew 28 genotypes of maize under well-watered conditions in these thin, clear containers. And then we used a flatbed scanner to take photos of their roots. And then after that, we ran a preliminary analysis on these three genotypes, and we found overall that the total number of root tips varied throughout growth. Whereas other features such as branching frequency remained relatively the same throughout growth, and and differences were more dependent on what genotype it was. And root tips is important for determining how many chemical interactions are occurring between the roots and soil. And overall, we found that the growth stage drove most of the variation in root characteristics, with most of the variation being explained by differences in root length and diameter, while differences in root architecture, such as branching frequency, was less apparent. And next, we're hoping to finish analyzing all of the photographs we took and then run all of this again under drought conditions.
Great. We have time for 2 questions.
Well, great job. I imagine that your work has a lot of agriculture implications. Could you maybe expand on where you can go from here with that?
Yeah. So my project is very basic, just kind of getting a general idea of what all of the roots look like. And next, once we do this under drought conditions, we'll get an idea of how they adapt to drought. And overall, the idea is that based on all of this information that we've gathered, eventually this could be used to develop crops that are more drought tolerant as the frequency and duration of droughts continues to increase.
Okay, I have a quick question. So why do you use this maize as your system to study drought resistance?
I think we chose maize just we could analyze several different genotypes, and they all had were all very, very different, and had really interesting differences in their phenotypic makeup.
Well, you did a great job. Thank you very much.